All right. Hello, everyone. My name is Michael. I'm a software engineer from Aixigo in Germany. We build web-based solutions for the financial sector, for banks and fintechs. And yeah, I've come to talk about architecture for the web client. And yeah, why is it even important? I probably don't have to convince you here because you came to the presentation. But if you'd like to tell others, well, we have to build increasingly large web applications, increasingly large amount of code that run on the web client. And we have to define the tools that we use for that. We have to find better tools because the code bases are becoming more complex, the teams are becoming larger. And we also have to have a common language and understanding, a vocabulary that we use to talk about these things. So what are the aspects of architecture that interest me here for this talk? There's complexity. The web application platform has been growing tremendously over the last couple of years and keeping up with the mobile platform. And so this complexity in the platform demands more complex applications. So people are building ever more complex web applications. And this complexity drives the platform complexity drives this. So this is one challenge that's become important over the last couple of years. And the next challenge is responsiveness or reactivity. And in the concept of web frontends, I'm not really, talking about fault tolerance or dying early or something like that. Reactivity means the application should always be quick to respond to the user. And when you fill out a form in a web application nowadays, you don't wait to submit the form before getting your feedback on validation and things like that. So there's a concept, bidirectional communication between the web client and the server. And then there's the third challenge that's of particular interest here in this talk. It's scalability. And with web applications, you might think about, well, scaling across multiple CPU cores or something like that. And that's not really very interesting for the web client. Most of the time, maybe you're building a 3D game or something, then that's important too. But, well, scalability I'm meaning here is scaling across teams of various backgrounds. You have not only multiple programmers working on a project, but actually multiple teams. And those teams tend to, favor different technologies, tend to have various different level of expertise, are very heterogeneous, and we'd like to support that using our architecture. So, and this is, well, the blueprint for the solution that's going to be the topic of this talk. This is the so-called unidirectional data flow, and it promises to simplify the development and maintenance of web applications. So it's actually not that new. 10 to 20 years ago already, you had these types of web applications where there was a database sitting on your server, and it had some contents that was interesting to users. They would make a request to the server, and they would serve the view, just an HTML representation of the contents of your database. Along with that view, they might get a form, which allowed them to add or modify the contents of the database. And, well, they post the form to an action, and that in turn on the server modifies your application state. So this flow of state, view, action or intent to modify the state and go full circle, it's actually not new. What's new is that over the last couple of years, this has also become an important topic for client-side software development. So who's responsible for that? Facebook. 2 years ago, they made a presentation where they told everyone, well, we have a huge problem getting our count of unread messages to work synchronously across the entire application. So as users navigated Facebook, they had various places where there was a possibility to read or send chat messages to other users. And apparently it was really difficult to get this count to sync up everywhere. And when you read a message, for it actually to stay read and not come back with 1 or 2 unread messages, you'd click it and, oh, actually nothing new. So yeah, users were very, very vocal about this. And so it turned out that an architectural problem had really become a user-facing problem. In case you can't really read this, so there's a Facebook wall message for Mark Zuckerberg, I think, where 890 people vote up for please improve the chat system. So yeah, so there was some degree of top-down pressure to modify this, to modify the architecture, to find out what is wrong with the current architecture, with the state that is redundant across multiple components, and find a better way to manage this. So what does the unidirectional flow look like that Facebook came up with? And they called this pattern the Flux Architecture. It's not just a software that you can download, it's an architectural blueprint that you can, well, employ in your application. So the state should be stored in those components called stores, where each store is responsible for a slice of the state, and those should not be overlapping, so they should be distinct. And then you have the view, which is at Facebook, they already used React to render the view, so that was a really good match because React is very well suited to re-rendering the entire UI every time you make a state change. So they could pick up this traditional way of rendering web applications, just reflect the current state of your database. Instead, they would just do it on the client, reflect the current state of your store, and re-render the entire component hierarchy in your app. And then, of course, the user doesn't just want to browse the read-only view of its application. So there's the so-called action creator, or actually multiple action creators for each thing that the user can do in an application. For example, mark a message as read, or create a new message, send it to someone. There's an action creator. It talks to the probably web REST API. And once it determines if an action can be carried out and should be applied to the application state that's stored on the client, it'll dispatch this action to the so-called dispatcher, which just notifies all the stores about what happened. So somebody sent a message to someone. Yeah. And all this happens on the client. And so if this is Flux, are there parts of this that I can download? Where do I have to fill in the blanks, or do I have to write everything myself? Well, that most certainly you don't. There's a large number actually of Flux applications nowadays, Flux implementations nowadays. So there's the traditional vanilla Facebook Flux implementation that not that many people use, I think. There's Yahoo Flexible, which is pretty popular. There's Alt.js, I think by Airbnb, and which is a bit more concise, avoids boilerplate. And then, Redux, I haven't put on here yet. I have a separate slide for that because it's a bit different, but it's also very popular. People mostly just say Redux instead of Flux nowadays. Yeah, and to get some meat to this theory, there's a little, the simplest possible webshop, you might say, that Dmitry Voronyansky wrote in 15 Flux implementations. So if you're into Flux, you want to know more and find out the right implementation for you, you might check it out and have a look at all the 15 different implementations. Well, what does it do? It just has a list of products that you can buy, and it has a shopping cart. So it allows you to add products to the shopping cart. That's one action. And then there's another action to check out the contents of that shopping cart. So logically, you would probably define two view components here, the product list view component and the shopping cart view component. And also, it's usually sensible in this case to define two stores. One store that manages the products that are available and their inventory, so you can determine if the product has been sold out. And, another store that manages the state of your current shopping cart contents. Yeah. And to have some actual code for this, I tried to further simplify the example that was based on Yahoo Flexible. And here we have a JSX implementation of the view component for the product list to the left. And if you're not familiar with JSX, it's the React way of generating HTML within the browser. So it's a way you can embed XML literals into your JavaScript code to simplify the generation of DOM. And the most important thing that this view component does is just renders the current state, which has received from the store, from the product store somehow. We'll see how. And it allows the user to press the button and to add this product to the shopping cart. For this, the action creator is called add to cart that we imported here. And yeah, it just renders the title, the price, and this image and a button, as we've seen in the demo. And well, this functionality-wise, this is pretty much everything that's needed to be done here. But there's some boilerplate code, where you have to connect this view component to the store. And that's actually, depending on the Flux implementation that you use, you have to write a lot of this boilerplate code for the initial provisioning of the data, for the querying of the store to get the data into your view component, and then for keeping up to date, getting the latest store contents whenever it changes and re-rendering the view. How this works in detail is not that important, it's just boilerplate. And then, you wire everything together and pull the other components in. Those are the shopping cart component, for example. I won't go into detail for that. It looks very similar. And yeah, you provide a render method that allows you to kick off your UI by doing the initial render. And then you're set for the view. And then having a go at the next part of our application, those are the action creators, which are a bit more simple. In the most simple case, you have a synchronous action creator. It's just a one-off call. The framework passes this done callback for you when you invoke an action creator. So you can do asynchronous calls too. And well, an action is just a string identifier that says, what happened or what should happen. A product should be added to the shopping cart. So the stores later know if they have to do something. And then some payload associated with this action. So in this case, what product was added to the shopping cart. And then there's the asynchronous case, where you say, okay, I'm going to check out this cart, for example. Yeah, there you have to talk to the REST API, obviously, to do a checkout. And then this REST API is wrapped here. You talk to it, and hopefully it'll say success checkout. You can also dispatch that action. So this allows you to, for example, show some sort of progress indicator in between those actions. And there you have an asynchronous done call. And possibly you should also handle the error case here, which is of course omitted in the example. And then there's the dispatcher, which is, I just didn't put anything in here because the Flux implementation is going to do that for you. It just calls all your stores in a row, and sometimes it has to do some other things. Because Flux is actually not that simple, so that's why you have to download a framework and not just write a for loop over your stores. So, for example, the product store, it keeps a list of available product and their inventory, and you can query this store to get all the products. This is what the view does for rendering. And it says, okay, I'm going to handle these methods. This depends on the Flux implementation. Sometimes you have just one big switch case statements where all the actions go through. With Yao Fluxible, it's like this. You say, okay, I've got these handlers and these associated callbacks. So when someone adds something to the shopping cart, I need to call my decrease inventory method because that's what I have to do when things are put into the cart. And handle receive is very simple. That's just the action that says, okay, when the application is kicked off, we need to put the initial products into the store. And decrease inventory is a bit more, weird, because the dispatcher is used, is accessed, and this wait for call is made. So in this case, the product store says when the inventory is decreased, I let the cart store go first. So the cart store is able to put something into the cart before I remove it from the inventory, because if the count goes to 0, the cart store might say, okay, there's actually nothing left, I cannot put anything into the cart. So this is a kind of functional dependency between those stores. And this is why the dispatcher is not that trivial. You can actually now create wait for chains that form a circle, and then you have maybe endless recursion or yeah, a deadlock. So it's a bit more complex. But those were the components of our application. And well, what advantages do we see to a more classical MVC approach, such as those using AngularJS or Backbone? You have a very strict separation of state in those stores, the UI and the view components, and the behavior in the actions and action creators. So you always know where to put something. That's nice. Each store value, each state value is stored exactly once, so you don't have those inconsistency problems that you had with a traditional approach, or that Facebook at least had with a traditional approach. And you have a very good testability, because you know exactly, a view is just supposed to transform a given state into a DOM tree, and you can check if this DOM tree looks good. A store just changes its states after an action happens. You can look at the state before and after to see if it's good. And it actually also simplifies server-side rendering, which is very hard to do if you're impossible to do if you're using AngularJS. You just say, okay, I generate this initial state on the server, send it to the client as a JSON object, and send the initial view as well, the initial HTML, and then the machinery just picks up on the client and starts updating the DOM when the next action happens. Of course, there are also a couple of disadvantages. The stores in a small application is just all of this. In small applications, all of these don't matter very much. But as you have more actions, you're prone to get conflicts, or you don't really know which stores actually work with what actions. And if you're going to change a payload of an action, what stores are going to be affected, things like that. There are these hardwired store dependencies, so the stores are not really isolated. This makes testing harder, and this makes swapping parts out harder. And stores are conceptually singletons. So for server-side rendering, they actually have one store instance per request, but you cannot just put 2 product lists into this application. So you'd have to rewrite your product list if you wanted to manage 2 sources of products that could be put into your shopping cart. And then there's this anti-pattern that I've glossed over in the code. Here, actually, mutable state is transported through these actions, which can lead to subtle errors. So in this case, the store just overrides its internal product state when new products are received. But at the same time, you get this payload through the add to cart action. And this is all the way through the view, from the past of this store, through the view, through the action creator, back into this method. And maybe the products have already been replaced since the action was fired. And in this case, you would modify this product here that you get passed through the payload, and nothing would happen. So you have to be careful not to mutate the objects that you put in the payload, and rather use some sort of ID to reference objects in the store. And this is really a crucial point that is addressed by Redux. So they eliminate this problem completely by saying, okay, all stores are not allowed to mutate their state internally. They just can, when processing an action, they're only allowed to completely replace the state. So with Redux, there's only one big state in your application. It's one big state tree. And whenever an action comes in, that replaces the state with a new state that reflects this user action. So to compare this diagram that we've seen before, we don't have the group of stores anymore. There's just this one store that's provided by the framework. And because there's only one store, we don't need the dispatcher anymore. Actions look very similar, only in this case, the view actually creates them and then dispatches them. That's a minor difference maybe. And how is the store actually changed or updated? For those, the so-called reducers are used. Those are functions that have this signature that we've just seen. They take a state or a subtree of the state, apply the action, return the new state. And with this functional programming pattern, every time an action arrives, the whole state tree is updated and replaced. Well, due to time constraints, I can't go into full detail on Redux, but it's, yeah, it really eliminates this mutable state problems that Flux has. Other than that, it also gives you some really nice, maybe unexpected advantages. Well, you have this functional composition, so if you're into functional programming, that's really, really great. It makes parts of your application easily testable, and then you're somewhat confident that when you put them together, they are still, well, they're still working. And you have snapshot replay capabilities. Because the state is replaced with a new state every time an action is dispatched, you can just always undo and go back to a previous state, because that'll still work. And you can just record all the actions, record them, send them to the server, and then, you know, someone has a problem, calls you, you can just replay them locally on your workstation and see what has gone wrong. And if you're doing it right, work with React APIs that allow you to, you know, perform some more efficient dirty checking, because when the reference doesn't change with Redux, a reference to a part of your state tree, you can be sure that the contents didn't change. So you may be able to skip the rendering of an entire subtree of your view, because you know the corresponding state tree didn't change. So, but for that, you really have to do it right. And JavaScript doesn't actually make it very easy to do this right. So mutating state is, JavaScript doesn't have built-in checking of immutability constraints. So if you're trying to keep your objects from being changed, you have to jump through some hoops. So, for example, you can use a transpiler which allows you, such as Babel, which allows you to use the spread constructor. So you can take an old object and create a new object where some property has been updated or added. Or you go really the hard way and call object freeze on your entire object tree recursively. But I would suggest doing this only for testing, because it's really heavy impact performance-wise. Or you can just go over and use something like immutable.js, which is actually very nice. It offers immutable data types with protect you against accidental modification. But it's also not, well, it's not just simple JavaScript objects anymore in this case. Good old JavaScript object and arrays are very easy to work with you know, you can always find someone who can work with these things. Immutable.js, you definitely have to learn it. And well, that amounts to the potentially steep learning curve. Goes for immutable.js, also goes for these functional programming paradigms. Some people think say it's very easy and natural to me. Other people struggle with it. But well, it's depending on how well you get along with it. And then there are the container components with Redux. So those are your top level components, like the product list or the shopping cart, that represent some parts of your application that the user can do useful things with. Usually it's that they know the whole state tree, and you have to be careful when you change things in the state tree, because maybe you need to add a new piece of data or remove something. Then, well, pretty much every part of your view might be affected. And so we actually, during this time where Redux was invented, it happened last year, I think, we came up with something different at our company, because we also were struggling with this scalability problem, working with multiple teams on the same project. And we've rediscovered an old programming architecture or pattern. It's called publish-subscribe. And it's actually used very heavily on the server side with messaging middleware. And well, its purpose is allow you to decouple your components. So yeah, decoupling is, it boils down to allowing your components to communicate, because you always have to have a way for them to do that. But without the sender component actually knowing about its receivers, or even if there are any recipient components when it sends a message. And the receivers should not need to know who actually sent a message. They have to look at it, evaluate what happened, what do I need to do now? And yeah, how can we do this? Well, there has to be some mediator, some man in the middle, which is called an event bus or event broker sometimes. And well, it just knows, you know, this component is interested in events regarding the shopping cart, and maybe that component is interested in all user actions having to do with receiving new products. And when an action happens that matches these subscriptions, then it will deliver the message through the correct recipients. And this selection happens through the configurable topics. So these are just string identifiers that allow you to form channels of communication in your application. And for us to realize this unidirectional data flow pattern that we've seen before, it actually looks somewhat like this. We have this event bus that I just mentioned, which is sitting in the middle. And then we have, well, two kinds of components, really. The view components that map very closely to the view components that you have in Flux or Redux. They're just trying to display some data. And, well, the user is able to, you know, invoke actions when interacting with these view components. And then there are the activity components, which play the role of the stores in a Flux context, but they no longer share the same global action namespace. Instead, they are connected to this event bus as well. And, well, their actions that they process, they are selected through event topics. So we have two types of event in the system. There are resource events. They are meant to transport state from the activity components to the view components for display. And usually they get the state from the REST API first. And then there are the action events, which which transport the user's intent to work with the application. And to segregate these components, we employ the concept of topics. And, well, this forms a kind of unidirectional flow, but on multiple layers in the application. So these topics, for example, this topic might stand for the shopping cart contents. A resource topic might be transported to just one specific view components, the shopping cart. And another topic, the list of available products, might be interesting to two more components. Well, this application, I guess not. Or an action may be generated by one view component, such as add this article to the shopping cart. And that may be processed by both the shopping cart activity, the store, if you will, and the product list activity. So, we have topics for both resources and actions, and those topics allow you to, well, configure after programming at configuration time what components should be able to talk to each other. So, and yet now we have a code example that's really similar to what we've seen before. We have a view component, which in this context gets its not its state from a store, but in the context of this PubSub application, gets its resource from the event bus. For this, we have a little helper library. So in-house, of course, we developed a library called Luxar patterns to work with this kind of project. And it talks to the event bus for you. And it says, okay, whenever the product's resource changes or the resource configured for the topic that is associated with products, then we need to re-render this view component. And for this, React is used here, and it just looks at the current state of this product's resource, and maybe it hasn't even received products yet. That's always possible with PubSub, so we also have to fall back to an empty list in this case, and it just renders those products. And then there's, well, the possibility for the user to add a product to the cart. And for this, we instantiate a publisher. This is also done through this patterns library. And yeah, it's also wired, okay, it's a bit small here, but it's wired to the topic configured under the add to cart feature. So in this case, the actual topics that are used on the event bus, those are not add to cart here and products here, but those are configured for these names. And the configuration looks like this. We have this list view component for products, and for the add to cart feature, there's an action configured, and that's this add-to-cart action. And the same action is configured on the activity that manages the state. And it's, well, it says, okay, decrement your inventory, use that feature when you receive this add-to-cart action. So the product's activity doesn't even need to know that there's a shopping cart, actually. It just wired to this action on the fly at configuration time. So it could also be invoked by some other event. And then there's this list resource, which transports the latest state. And, well, it's called products-list or product-list. And it's transported from the activity to the interested view components. Then for the other half, there is an activity component, and this is also managing the product list like we saw in the Flux example before. And it interfaces with this patterns library and is able to, well, publish the current list of resources when all other components are listening. So there has to be some kind of lifecycle events published by the event bus itself that says, okay, everyone's listening now, has made the subscription, so you can start publishing data. And also, this activity is responsible for updating the products list state when a new add product action was received, or in this case, the decrement inventory, because that's what it's called in here. And for this, it doesn't just modify the product, as we've seen in the Flux example, which was the problem with the mutation of state. Instead, it looks up the product in the current state and then updates the inventory there. So it wouldn't even be possible to modify the product that is coming in, because the event bus in this framework that we built always duplicates everything that it receives through a publish call. So effectively, components cannot talk to cannot modify each other's state and cannot damage each other. And also, they're not allowed to expose any API. So we do that by principle. They are only allowed to talk through these events. So when you just remove a component from the application, this should never break the application. Maybe some components don't get the data, but usually you're able to remove a couple of those components and everything, well, they're just missing from the screen, but the application doesn't break. So yeah, what's this solution? It's a solution track. We've come up with this framework that provides us with an event bus. The framework is called Luxar.js, and it doesn't only have the event bus. It also takes care of component configuration. We use a JSON schema for that, so you add the schema to your component to allow specific properties to be set. It determines what types of topics can be configured, or maybe you just want to set some additional values, such as a web service API URL, something like that. And then it also allows you to compose these components, also using a declarative JSON format. So these component compositions then look themselves like components from the outside. And it manages this life cycle, tells the component when the others are listening. It has these services that we saw, for example, to render a React component. And it offers some development tools. For example, you can visualize what events go through the application, and how the components are actually structured together. I can just show this quickly because I think there's enough time. If I get this, yeah. So we have the same demo built with this PubSub framework, and I just added this button to open this developer widget, which is also just another component, and it's able to tap into the stream of event that goes through your application and shows you what's going on, who are the collaborators, who published something, who's receiving. You can actually also look at the contents, which is a bit hard on this display, but it makes it a bit transparent what's happening in your application. And then you can visualize the structure, which allows you to see if you wired together your components correctly, because it just looks at the JSON definition of your page and matches up these topics. And then you can do things like filter by the components. So now it shows only events that have to do with this with this component I just selected here. Yeah, and then back to the question of architecture. Yeah, what do we think? What are our experiences with this pub/sub solution as compared to a traditional Flux or maybe Redux application? So yeah, the advantage clearly is the decoupling of components, which allows you to isolate, test components in isolation, but also to reuse them across application or across different pages in your applications maybe. You make architecture visible. You see where components are connected. If you modify one component, which components will be affected by this. It makes composition more flexible compared to Flux because you're free to define your own patterns. Actually, we defined, for example, a pattern, an event pattern that transports flags through the application, so Boolean state, which is similar to a resource, but simpler for those cases where you just need to know if a pop-up window is open or something like that. And maybe you have different things you might like to abstract, for example, data streams. And it also says every component is a black box because it doesn't have any API. It really doesn't matter if it's implemented using a functional approach or an imperative approach. So if you have development teams with different backgrounds, and there are some hardcore functional developers that like to implement their component state using, reduce operations, then they can do that. And if you have people who are fans of reactive extensions, then, an event bus subscription is really simple to an observable subscription. In RxJS, they can put that thing on that, and then work with RxJS in their component. And you can also, use a different view technology if you don't like React. Originally, we started out with Angular 1, and we're still using AngularJS 1 for our view components mostly. But recently, you can also use React. It's just a thin adapter layer that you have to write. Of course, also other frameworks. Well, and there's the drawbacks. The ecosystem is definitely not comparable to what you get with Flux or Redux. You walk the untread path here. But we're using it. We've been using it with financial institutions for 2 to 3 years now, and so we are very confident in it working. But you still have the freedom to make mistakes when you determine which components are in your application and how you wire them together. There's always the possibility of, for example, going too small. Originally, we defined components that were just one button or one table row or something like that, and then it became very messy. You can imagine trying to draw this wire diagram with hundreds of components. Well, even if we have compositions, it simplifies things a bit, but it can become messy. So you really should try to identify components that have actual business value to the end user, and that makes things very approachable usually. And we do have applications that have hundreds of those components, and they are very manageable. So 100 instances, I should say, but tends to 100 of component classes. And then is there still Flux? So originally we said, let's talk about Flux and go beyond that. For Dan Abramov, the creator of Redux, all that counts is you have unidirectional data flow and you have those changes described as plain objects. In that sense, both Redux and the publish-subscribe-based approach are actually more Flux than Flux, because in Flux you still have this non-reactive way of creating actions and dispatching them at the same time. So actions as plain objects, the event model fits that very well. And Andre starts as this to say, it's cool that you're inventing a better Flux by not doing Flux at all. Also talking about Redux here, of course, but we like to think that's somewhat true of our approach as well. And it's actually not that important. It's terminology, but it's somewhat similar to Flux, what we're doing. And then you have the highly subjective judgment of things. All of those approaches are unidirectional flow. We set out 3 main goals that our architecture should solve. And complexity handling, well, maybe if you do Flux right, it'll also work, but you also always have this problem with the mutable state. The reactivity, yeah, also depends how you use Flux, but as I said, the action creation is dispatching them, hurts a bit. And then scalability, meaning not performance-wise, but developer team-wise, we think, yeah, that we really are onto something here, because we are actually developing relatively complex single-page applications with this across multiple teams, and they don't get in the way of each other too much. So that kind of works. And then there's these problems, and well, is a snapshot record replay important to you? Maybe, maybe not. And the other things, learning curve. If you're already a functional programmer, then that's a non-issue with Redux. So these things are very dependent on your situation. Longevity, Redux is very young. PubSub, the pattern itself has been there for 20 years. So I think those methodologies like event sourcing, all the patterns around PubSub, they apply to this technique that we showcased here. But of course, what we are doing in particular, maybe too early to tell. Yeah, and well, that's about it. Yeah, the framework is called Luxor.js, if you want to look into that. The slides should be on GitHub. Maybe I still have to make them public, but they will be very soon otherwise. And I was wondering if there are any questions now. All right, then. Thanks for your attention, everyone.